Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So to solve this problem, I'm going to first start by taking the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And notice that for multiplication, I can switch the places of these two numbers. So this is the same thing as a to the power of n times m, right? Now, if I have something in the form a to the power of m times n, and this is equal to a to the power of m to the power of n, then a to the power of n times m, this should equal a to the power of n to the power of n. Meaning, all four of these are equal to each other. So my point for telling you all this is that a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So now coming back over here, we have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. And we can think of x to the power of 3 here as m and 3 as n. So now I can switch the places of these two. So now I get x to the power of 3 to the power of x to the power of 3. And this is equal to 36 to the power of 3. Now from here, I'm going to rewrite 36 as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. And again, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 times 3. And 2 times 3, that's equal to 6. So I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 3 is equal to 6. And now if I take the cube root on both sides, I get x is equal to the cube root of 6. Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So I'm going to first start by letting y equal 2 to the power of x. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 3x, that's going to equal 2 to the power of x to the power of 3. Now I have this plus 2 to the power of x is equal to 10. Now I'm going to let 2 to the power of x equal to the variable y. So I get y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. And now y, I can rewrite this as 5y minus 4y. Now from here, I can factor by grouping. And before I do that, I'm going to switch the order of 5y and 4y. So I now have y to the power of 3 minus 4y plus 5y minus 10 is equal to 0. So now if I factor by grouping, I can start with y to the power of 3 minus 4y. I'm going to factor out y, so I get y times y squared minus 4, plus from 5y minus 10, I have 5 times y minus 2 is equal to 0. Now, y squared minus 4, I can rewrite that as y plus 2 times y minus 2. And now from here, notice that the only common factor for all these terms is y minus 2. So I have y minus 2 times y plus 2 plus 5 is equal to 0. And now if I simplify this, I get y minus 2 times y squared plus 2y plus 5 is equal to 0. And now I get two equations. I get y minus 2 is equal to 0 and y squared plus 2y plus 5 is equal to 0. So for y minus 2 equals 0, y is obviously equal to 2. And for y squared plus 2y plus 5 equals 0, we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I get y is equal to negative 2 plus or minus the square root of b squared, so 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a. So 2 times 1. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16, over 2. And I can write this as negative 2 plus or minus the square root of 16 times the square root of negative 1 over 2. And this is equal to negative 2 plus or minus the square root of 16 times I, because the square root of negative 1 is equal to I. And the square root of 16, that's equal to 4. So I get y is equal to negative 2 plus or minus 4i over 2. Now if I divide 2 with both these terms, I get y equals negative 1 plus or minus 2i. Now, remember how we let 2 to the power of x equal to y. So I get 2 to the power of x is equal to 2i minus 1. And I get 2 to the power of x is equal to negative 2i minus 1. Now, we can't actually take the power of a positive number and make it equal to something with I. So there's no solution for this, meaning that we can only use y equals 2. So I get 2 to the power of x equals 2, meaning our only solution for x is 1.